In this video, we're going to go over the examples of practice using exponent rules. Make sure you try this first. If you have not tried these problems on your own, pause the video, do this first. So here we go. For number 9, you are multiplying two exponential expressions with the same base. So you use the product rule, which means you add the exponents. And you end up getting 2 to the power of 7. And you definitely want to leave that there because that is a very big number. For number 10, it is also the product rule, and you are multiplying two exponential expressions. So you add the exponents, but this time the exponent is a negative number. So you have to continue, use the negative exponent rule. So the negative 6 is in the understood numerator. That negative sign tells the exponential expression that it is on the wrong side of the fraction. It needs to move to the denominator where it can keep the 5, it can keep the 6, but now it's going to be positive and happy. Then, number 11, we have a 0 exponent on variable t. And as far as you need to be concerned with in this class, a variable to the 0 power is 1. And so what is 1 times t cubed? It's just t cubed. And that problem is over. For number 12, we have 3 things multiplying. So there's an understood exponent of 1 on this very last a. I can just go through and add all of the exponents no matter how many things I have multiplying together, as long as they have the same base. So exponents negative 4 plus 6 plus 1, we end up with exponent 3. For number 13, we are now having two exponential expressions that are dividing. The quotient rule says that you will subtract the exponents in the order of numerator minus denominator. So 3 minus 5 gives me negative 2, but to simplify with a negative exponent, you need to change the side of the fraction. Right now, it's in an understood numerator, so move it to the denominator. The b stays, the 2 stays, but now they're all positive and happy. For number 14, quotient rule again. So subtract the exponents when you have the same base for what is being divided. 5 minus negative 2 is a 7, and you're good to go. Leave it as 7 to the 7 power because that's a really big number. For number 15, we again have the quotient rule. And you want to remember that there is an understood 1 exponent every time a variable is written down by itself. So the quotient rule says subtract numerator exponent minus denominator exponent, and you get c to the 7th power. And then number 16. Now, there are 2 ways you can go about this problem. If you don't like dealing with so many negative exponents, you can start by moving anything with a negative exponent to the other side of the fraction so you don't have to deal with subtracting negatives. So my numerator at the very beginning is 3 to the negative 7. That moves to the denominator as 3 to the positive 7. Also at the beginning of the problem, I have 3 to the negative 2 in the denominator, so that can move to 3 to the positive 2 in the numerator. Then you can just go through your nice little quotient rule of exponents and subtract the 2 exponents, numerator minus denominator. You get a negative exponent, and then when you have a negative exponent, you write it on the other side of the fraction, 1 over 3 to the positive 5 power. And that's it with the examples. Good luck.